When installing a grounding electrode system, it's critical to adhere to the National Electrical Code, or NEC, requirements for conductor sizing. The question focuses on a three-phase service utilizing parallel 350 NCM copper THHN conductors, each with a number 2 bonding jumper. The grounding electrode system consists of two 8-foot ground rods spaced 8 feet apart. The query is whether a number 6 grounding wire is permissible to connect to both rods, considering it's the sole connection, or if a number 2 wire is mandated by NEC Table 250.66. To address this, we must examine the relevant sections of the NEC, specifically Article 250, which covers grounding and bonding. The grounding electrode conductor, or GEC, connects the service equipment, typically the neutral bus in the service panel, to the grounding electrode, such as ground rods, metal water pipes, or concrete encased electrodes. The size of the GEC is determined by the size of the service entrance conductors. NEC Table 250.66 provides the guidelines for sizing the GEC based on the size of the service entrance conductors. In this scenario, we have parallel 350 NCM copper THHN conductors. To determine the equivalent size of the service entrance conductors, we need to add the ampacity of the parallel conductors. The ampacity of 350 NCM copper THHN conductor is found in NEC Table 310.16, which depends on the insulation type and temperature rating. Assuming a 75 degrees Celsius rating, the ampacity of a 350 NCM copper THHN conductor is 310 amps. Since we have parallel conductors, we multiply the ampacity by the number of parallel conductors. However, for the purpose of grounding electrode conductor sizing, we are more concerned with the circular mil area than the ampacity. The important consideration is to reference Table 250.66 based on the size of the service entrance conductors, without applying any derivative or adjustment factors. To properly utilize Table 250.66, we need to determine the equivalent size of the parallel 350 NCM conductors. While adding the ampacities is useful for overcurrent protection for grounding purposes, the code refers to the conductor size in American wire gauge or AWG or thousands of circular mils or MCM. The NEC mandates that the grounding electrode conductor must be sized no smaller than specified in Table 250.66 based on the size of the service entrance conductors. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. According to Table 250.66, for service entrance conductors larger than 3/0 AWG copper but not larger than 350 MCM copper, a minimum number 2 AWG copper grounding electrode conductor is required. This applies when the grounding electrode is a ground rod, ground plate, or other electrodes as described in NEC 250.52. However, an exception exists for concrete encased electrodes and ground rings, where the grounding electrode conductor need not be larger than number 4 AWG copper. In this case, since the grounding electrodes are two 8-foot ground rods, the general rule applies. Therefore, the grounding electrode conductor connecting the ground rods to the service equipment must be at least a number 2 AWG copper conductor, regardless of the number 6 AWG wire being the sole connection to the rods. It's important to note that the number 2 bonding jumper per pipe is related to equipment grounding, ensuring a low impedance path for fault current back to the source. This is separate from the grounding electrode conductor, which connects to the grounding electrode. The bonding jumper connects metallic parts, such as conduit, enclosures, and other non-current carrying metal parts to the equipment grounding conductor or the grounding electrode conductor. The purpose of equipment grounding is to provide a path for fault current to trip the overcurrent protective device, such as a circuit breaker or fuse, in the event of a ground fault. The grounding electrode system, including the ground rods and the grounding electrode conductor, serves a different purpose. Its primary function is to stabilize the voltage to earth and provide a path for lightning and other transient currents to dissipate into the earth. Therefore, the size of the bonding jumper is determined by NEC Table 250.102, based on the size of the service entrance conductors, while the size of the grounding electrode conductor is determined by NEC Table 250.66, also based on the size of the service entrance conductors but with different criteria. In this specific scenario, the question is whether a number 6 AWG grounding wire is sufficient to connect the two ground rods, given that it's the only connection to the rods. However, according to NEC Table 250.66, the minimum size grounding electrode conductor for a single grounding electrode is a number 2 AWG copper. Therefore, a number 6 AWG grounding wire cannot be used to connect the two ground rods. A number 2 AWG copper wire must be used to comply with the NEC requirement. Furthermore, it is crucial to ensure that the connections to the ground rods are made with listed and labeled connectors suitable for direct burial. These connectors must be corrosion resistant and able to withstand the environmental conditions in which they are installed. The grounding electrode conductor must be connected to the ground rods in a manner that provides a permanent and reliable connection. The NEC also specifies requirements for the installation of ground rods, including the depth to which they must be driven into the earth. Typically, ground rods must be driven to a depth of at least 8 feet, with the top of the rod flush with or below ground level, unless rock bottom is encountered. If rock bottom is encountered, the ground rod can be buried in a trench that is at least 30 inches deep. In addition to ground rods, other types of grounding electrodes are permitted by the NEC, including metal water pipes, metal building frames, and concrete encased electrodes. However, ground rods are one of the most common and cost-effective types of grounding electrodes, particularly in residential and commercial applications. It is also important to verify the local amendments and requirements in the specific jurisdiction. Local codes may have more stringent requirements than the NEC, and it is crucial to comply with all applicable codes and regulations. Failure to comply with the NEC and local codes can result in fines, penalties, and even legal action. Additionally, it can create a safety hazard and increase the risk of electrical shock or fire. Therefore, it is essential to consult with a qualified electrician or electrical engineer to ensure that the grounding system is properly designed and installed. In summary, when dealing with a three-phase service using parallel 350 MCM copper THHN conductors and two 8-foot ground rods, the grounding electrode conductor connecting the ground rods must be at least a number 2 AWG copper wire, as required by NEC Table 250.66. A number 6 AWG wire is not sufficient and would violate the NEC requirements. Always consult the latest edition of the NEC and any applicable local codes to ensure compliance and safety. Remember that the grounding system is a critical component of the electrical system, and it must be properly designed and installed to protect people and property from electrical hazards. The information provided is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer for specific recommendations and guidance on your electrical system. Firstly, always refer to the latest edition of the National Electrical Code, or NEC, and any applicable local codes and regulations. Secondly, accurately determine the size of the service entrance conductors to properly size the grounding electrode conductor. Thirdly, use NEC Table 250.66 to determine the minimum size grounding electrode conductor based on the size of the service entrance conductors. Fourthly, ensure that the grounding electrode conductor is properly connected to the grounding electrodes using listed and labeled connectors. Fifthly, verify that the grounding electrodes are installed in accordance with NEC requirements, including depth and spacing. Sixthly, consider the type of grounding electrodes being used, as different types may have different requirements for grounding electrode conductor size. Seventhly, be aware of any local amendments or requirements that may be more stringent than the NEC. Eighthly, consult with a qualified electrician or electrical engineer to ensure that the grounding system is properly designed and installed. Ninthly, maintain accurate records of all electrical work, including grounding system installations and modifications. Lastly, prioritize safety and always follow established safety procedures when working with electrical systems. For service entrance conductors that are 3/0 AWG copper or larger, but not larger than 350 MCM copper, The minimum size grounding electrode conductor is number 2 AWG copper. If the service entrance conductors are larger than 350 mcm copper but not larger than 600 mcm copper, the minimum size grounding electrode conductor is number 1/0 AWG copper. If the service entrance conductors are larger than 600 mcm copper but not larger than 1100 mcm copper, the minimum size grounding electrode conductor is number 2/0 AWG copper. If the service entrance conductors are larger than 1100 mcm copper, the minimum size grounding electrode conductor is number 3/0 AWG copper. The grounding electrode conductor must be connected to the grounding electrode, such as a ground rod, ground plate, or metal water pipe, in a manner that provides a permanent and reliable connection. The connection must be accessible for inspection and testing. The grounding electrode conductor must be protected from physical damage and corrosion. If the grounding electrode conductor is exposed to physical damage, it must be protected by conduit, metal armor, or other suitable means. If the grounding electrode conductor is subject to corrosion, it must be made of corrosion-resistant material or protected by a corrosion-resistant coating. The grounding electrode system must be tested to ensure that it is effective in providing a low impedance path to ground. The testing should be performed by a qualified electrician or electrical engineer. The testing should include a ground resistance test to measure the resistance of the grounding electrode system to earth. The ground resistance should be low enough to ensure that fault currents will flow to ground quickly and safely. The NEC provides guidelines for acceptable ground resistance values. If the ground resistance is too high, additional grounding electrodes may be required to reduce the resistance to an acceptable level. The grounding electrode system should be inspected regularly to ensure that it is in good condition and that all connections are tight and corrosion-free. Any damaged or corroded component should be replaced immediately. The grounding electrode system is a critical component of the electrical system, and it must be properly maintained to ensure its effectiveness. By following these guidelines, you can help to ensure that your grounding electrode system is safe, effective, and in compliance with the NEC. The proper sizing and installation of the grounding electrode conductor are essential for electrical safety and compliance with the NEC. Always consult with a qualified electrician or electrical engineer for specific guidance on your electrical system. Also, be aware that while the ground rods are 8 feet apart, that may be close enough to be considered one grounding electrode. In some cases, the authority having jurisdiction, or OJ, may require additional ground rods or a different type of grounding electrode to ensure an effective grounding system.